Cambridge IGCSE, May-June 2021, Paper 22. Question 1. Which piece of apparatus is the most suitable for measuring the mass of a pencil sharpener? Option A says digital balance. So let's look at the function of a digital balance. A digital balance is used to measure the mass of a substance quickly and accurately. Therefore, option A is correct. We can look at the other options also. Option B says measuring cylinder. So measuring cylinder is used to measure the volume, not mass. And Newton meter is used to measure the forces acting on an object. And finally, option D, ruler. The function of a ruler is to measure the length of an object. Therefore, the correct answer is option A. Question 2. 4 balls with different masses are dropped from the heights shown. Air resistance may be ignored. Which ball has the smallest average speed? So here very important keyword is air resistance can be ignored. So we can understand all these balls are falling under gravity, because the only force acting on this ball while it is falling is its weight, and which are acting downward. As the air resistance is negligible, which is mentioned in this question, there is no resistive forces or there is no upward forces acting on the ball. So the only force acting on each ball is its weight. So the only acceleration on each ball will be the acceleration due to gravity. So the acceleration on each ball will be acceleration due to gravity, which is g, and we know that that value is 10 meter per second square. So for every ball, the acceleration will be acceleration due to gravity, and that is 10 meter per second square. So that is the first point we should think about. The acceleration on each ball will be due to its weight. Hence, these all balls are under free fall. So the acceleration due to gravity which will acting on this ball will be 10 meter per second square. In this question, we need to calculate out of these 4 balls, which ball has the smallest average speed. So speed, average speed. Which one will have a smallest average speed? This is what we need to calculate. Here we can use the equation of acceleration. As we know that the equation of acceleration is rate of change of velocity or final velocity minus initial velocity over time. And all these balls are dropping from the rest, or its initial speed will be 0. So the u for all these balls will be 0. That is the initial speed. So for all these balls, we can understand its initial speed is 0. And we have already seen acceleration on this ball is acceleration due to gravity, that is g. So by using these two values, again we can write the equation of acceleration, that is g for these balls will be equal to final velocity over time. Now we can make the v as the subject or the final velocity as a subject, because we have to calculate about the average velocity. In order to check the value of average velocity, we can make v as subject. So we will get v is equal to g times t. And here it is very clear that the g, acceleration due to gravity, is a constant value and its value is always 10. That's why we can say it's a constant. Since it is a constant, from this relation we can understand the velocity is directly proportional to time. Or using the same equation, that is velocity is equal to g times t, which we have already understood. The same equation I am writing here. And this is the final velocity. But what will be the average velocity? Initial velocity 0, final velocity maximum. So the average velocity will be the in between the value or the half the value. So we have to take the half of the final velocity. That will be half of final velocity is g into t. So we can write down average velocity will be half times G times T. So again we can see this half and G, these are constant values. Therefore V average of these balls, or average velocity or average speed of these balls, is directly proportional to the time taken to reach to the ground. Now we need to check which of these ball will have the least average speed. We have already concluded that average speed is directly proportional to time in this particular case. Now in order to check which ball will have least average speed, we just need to check which ball will be taking least time to fall down. So by looking at the figure, it's clear that the ball given in option A has to travel a less distance, so it will take only less time to reach at the ground. Here one important thing you should understand, that even though the mass of each ball given in each options are different, but their acceleration or rate of increase in speed is same, and that is G, gravitational constant 10. So for every ball, doesn't matter how much its mass is, its acceleration is constant. Therefore we don't have to think about its mass in order to check that time taken to reach the ground. So we can simply check it the distance, and we can see in option A the ball has to travel a less distance, so the time taken will be less. Therefore if the time taken is less, then the average speed will also be less. Therefore the correct answer is option A. Question 3. A ball is thrown vertically upwards through the air. Air resistance acts on the ball. Which graph shows how its speed varies with time? So in this question, we need to plot a speed time graph of a ball which is thrown vertically upwards. So we know that once we throw a ball upwards, the ball will move upwards, but since it is moved against gravity, speed will gradually reduce and it will reach a speed of 0 at the end. So when the ball reached at maximum height, its velocity will be 0 as it stops completely. But its velocity will be maximum initially. And later on speed will gradually decreasing because this ball is moving opposite to the direction of the weight, or the ball is moving against the gravity. So definitely its speed will gradually reduce to 0. And at maximum height, its speed will be 0 and the ball stops. If there was no air resistance acting on this ball, the negative acceleration acting on this ball when it is moving upward will be acceleration due to gravity. Or instead of saying negative acceleration, we can say deceleration. The reason is the force is acting to the opposite direction of the motion. So if there is no air resistance, then the deceleration value will be G, that is 9.81, or we can consider as 10 meter per second square. This is the case for the motion of the ball without air resistance, but in this question it's mentioned that we need to consider air resistance also. So now look at the ball and we can check what will be the air resistance direction, or the direction of the force air resistance acting on the ball when it is moving upwards. So we know that ball is moving upwards. So when it is moving upwards, the force due to air resistance will also act in the opposite direction of motion. Therefore, not only the weight of the ball, but the force due to air resistance is also will act in opposite direction of the motion where the ball is moving upward. So for every position when the ball reached, its weight will be always acting downwards, as we can see. But what about the air resistance? Here we need to recall one important concept about air resistance, and this is very important. You will have to use in these kind of motions where air resistance exists. That The force due to air resistance is directly proportional to the speed. When speed of a motion increases, the force due to air resistance will increase. So this relation is very important. We need to use it here also. That is, the force due to air resistance will increase when the speed of the motion increases. So here when the ball is moving upward, we have already seen, since it is moving opposite to the gravitational force, speed will reduce. So that is something very important. When the ball is moving upward, its speed is reducing. Now we can use the relation between force due to air resistance and speed. When the speed reduces, we should understand that the force due to air resistance will also reduce using this concept. So the force due to air resistance will be maximum at the initial position or at the starting of the motion of the ball, but later on this force due to air resistance will gradually reduce, and at the top the force due to air resistance will be zero. Now we can look at the net force acting on the ball. Initially the net force is due to weight and force due to air resistance. So this will be maximum at the starting position, and this net force will gradually reduce. It will be less as the air resistance is less. That means when the net force is maximum, its acceleration will also maximum. Then the acceleration will reduce. So as the net force reduces, acceleration in opposite direction of the motion, or we can say the deceleration, which will reduces comparing to the initial value. Therefore, from this motion of the ball from starting position to the maximum height, or when the ball moves upwards, we can conclude two important points, that is its speed is reducing from maximum to zero. And about the deceleration or negative acceleration, which is also reducing from a maximum value to a less value. Now we can check which graph represents these two conditions, where the speed should reduce maximum to zero, but the acceleration also should reduce. Now the next question, from speed time graph, how can we check the acceleration or deceleration? Here we need to know the point that the gradient of a speed time graph will give you the value of acceleration. Here when the ball is moving upward, we will get the negative acceleration or deceleration. So just look at the gradient which defines the acceleration. So I repeat, we have to check two important points. Speed should reduce from maximum value to zero, and its acceleration, that means the gradient, should also reduce from a maximum to a less value. Gradient should not be constant. It should reduce from maximum to a minimum value. So the graph in option A, its speed is reducing from maximum to minimum, 0. So the first condition satisfies, but when you check its gradient, which gives you idea about acceleration, you can see its gradient or its slope is not reducing, but it's a constant. Its slope, you can see it is constant value. So it's not satisfying the conditions which we have discussed. Therefore, the first option is wrong. Now we can look at the second graph, where you can see speed is reducing from maximum to 0. So the first condition satisfies, and the second condition, the acceleration or the gradient of the graph should reduce from a maximum to minimum. So let's check the gradient. Gradient is nothing but the slope. In order to check the gradient or slope, you can draw straight lines at the different parts of the graph, the lines passing through that point. So here you can see the slope is actually increasing, or these lines are becoming more steeper. More steeper means more the slope, so more the gradient, so more the acceleration when it is reaches at the top height. That is wrong. This value of acceleration should reduce. Now when you look at option C and D, you can see that its slopes are reducing. As slopes reducing means its acceleration is also reducing. So it satisfies both the conditions. When the ball moves upwards, speed is gradually reducing to 0, and even its gradient is also reducing, so that its deceleration or negative acceleration is also reducing. So the first part of the graph in both option C and D, it satisfies the graph of a motion of a ball which is moving vertically upwards till it reaches maximum height. Now we can see what will happen to the graph when the ball falls downwards from maximum height to ground. So we have already seen when the ball reached at the maximum height, it stops completely, then it will start to fall down and it will reach to the ground with a maximum speed. So when we are looking at the speed, initially the speed will be 0, then speed will gradually increase because it's moving in the same direction of the force due to gravity. So its speed will gradually increase and speed will be maximum at the end. Now we need to check about the acceleration acting on the ball. So when the ball moves downwards, the first point we have already seen, it's about its speed. The speed will increase, or it will change from 0 to a maximum value. Next we need to check about the acceleration acting on the ball when it is moving downwards from starting position to the lowest position. So in order to check about the acceleration, we should always look at the force acting on the object. So we can see the weight will be acting downwards at all the position, and the weight and the direction of the motion are acting in the same direction. So the ball will have a positive acceleration, but we need to check about the air resistance, and here you have to use this concept of air resistance which we have discussed, that when the speed increases, the air resistance will increase. So here also the speed increases, so the air resistance will definitely increase. So initially when the speed is 0, the air resistance will be 0 at the maximum position, but gradually as its speed increases, there will be upward air resistance, because air resistance is a force which will always act in the opposite direction of the motion. And when the ball is reaching at the ground, the ball will have a maximum speed, therefore the force due to air resistance will also be maximum. Now when we are looking at the net resultant force acting, we can see it will gradually reduce, because net resultant force will be maximum at the top and it will reduce and it will be minimum at the bottom, because at the bottom position, as you can see, the weight is acting downwards but a very high resistive force is acting in opposite direction. So in order to calculate net force, we need to subtract this. Therefore the net force will be minimum when the ball is at the final stage. When the net force is minimum, the acceleration will also be minimum, so that during this motion, that is the motion of the ball from upwards till downwards, we can conclude that as the net resultant force reduces due to the increase in air resistance, which will cause a less acceleration, or acceleration will also reduces. So that is the second point we should keep in our mind, that is acceleration will reduce, or acceleration reduces. And what is acceleration? Acceleration of a speed time graph is nothing but the gradient of that graph. Now we can again look back at these two graphs in option C and D, and we can check which graph satisfy these two conditions. Speed should reduce from 0 to maximum, increase from 0 to maximum, and acceleration should decrease. Acceleration means nothing but the gradient of the graph should reduce. So therefore we can look at the option graphs in option C and D separately. So when we are looking at option C, when you check the gradient, that is a straight line passing through that point, you can see the gradient is become more steeper or a greater value. So here when the ball is falling from maximum height to ground, as this line is becoming steeper, we should understand here it represents an acceleration which is increasing or increases. But for this case of ball, when it is falling downwards, we have seen the gradient should reduce or the acceleration or should reduce. So we can check the gradient of this line. So when you plot straight lines, you can see these gradients are becoming less steeper, or the lines are becoming less steeper, or gradients are reducing. That means the acceleration is reducing. So the graph in option D satisfies the motion of ball when it is moving downwards. Its speed is increasing from 0 to a maximum value, and acceleration is also reduces. As you can see, its lines are becoming less steeper. Therefore, the correct answer is option D. Question 4. What is the best description of the meaning of the mass of an object? So the definition of mass of an object is the property of an object to resist the motion of that object. Therefore, the statement in option C describes the mass correctly, that the resistance of the object to change its motion. This is the definition of mass, so that the correct answer is option C. Question number 5. A measuring cylinder contains 40 centimeter cube of water. A stone of 94 gram is lowered into the water so that it is fully submerged as shown. So we can see there is a cylinder which consists of water. Initially, before putting the stone, the level of water level or the volume of water was this much, that is 40 centimeter cube. Once we put this irregularly shaped stone, definitely the level of water will increase, and the new volume we can see 76 centimeter cube. What is the density of the stone? So we need to calculate density, and we know that density is mass of the stone over volume of the stone, where mass of the stone is already given, but we need to calculate volume of the stone. So how can we calculate this volume of the stone? Which we can calculate the total volume or the new water level or new volume where we have already added the stone. So the new volume minus the volume of water without the stone. So that will give you the volume of the stone. And we already have the values. New volume is the new water level that we can identify from the figure, and that is 76 centimeter cube minus volume of the water or the initial level of the water before putting this stone, that is 40, which is already mentioned in the question, and we will get 36 centimeter cube. Now we have the volume of the stone, and mass is the stone already given in the question. So we can substitute that mass is 94 gram over volume is 36 centimeter cube. And the answer 2.6 gram per centimeter cube. Correct answer is option D. Question 6. The extension load graph for a spring is shown. The unstretched length of the spring is 17 centimeters. So this is the original length of the spring. When an object is suspended from the spring, the length of the spring is 19.2 centimeters. What is the weight of the object? So here we have a spring and its original length is given. That is, so the original length of the spring is 17 centimeters, but a weight added to the spring, it extends, and the new length of the spring, there is some object or some weight has added, so that the spring will extend definitely and its length will increase, and its new length, which is given 19.2 centimeter, and we need to find what is the value of this weight. So here we have the original length, we have the new length, so we can calculate the extension. If we know the extension, we can find what is its corresponding load from the graph. So first we can find the extension. Using the equation, extension of a spring will be is equal to its new length minus its original length or its initial length before adding the mass. Here everything we have, its new length is 19.2 minus original length is 17. So the extension of the spring is 2.2. Now we can 2.2 centimeter. Now we can look at the graph and check which point of the graph represent 2.2 centimeter, and you can see this position represent 2.2 centimeter. So when the extension of the spring is at this position, what is the corresponding load? That also we can identify by stretching on y-axis and checking at which point it intersect with the y-axis value. So we can understand when the load is 3 Newton, the spring will have an extension of 2.2. So the correct answer here is option D, 3 Newton, which we can get from the graph. Question number 7. A satellite orbits the Earth in an anti-clockwise direction at constant speed as shown. When the satellite is in the position shown, in which direction does the resultant force act upon it? So we can see in this figure there is a satellite which moves in a anti-clockwise direction which rotates around the Earth, and at all the point it is having a constant speed. Now we need to check when the satellite is at this position, in which direction there must be a resultant force is acting. So here we can understand that the satellite is moving in a circular path, or the motion of the orbit is a circular motion. So in circular motion, there are some conditions it will be satisfying, then only the objects can move in circular motion. So that important points I will write it here. The first one, there must be a net force acting on the object. So net force should act on an object in order to move in a circular path. And what should be the direction of this net force? This net force should always direct to the center of the circular path, or simply the center of the circle. This is very important conditions. Any object, if it wants to move in a circular path, it should satisfy these conditions. Then only the object can keep moving in a circular path. So here this satellite, in order to move in a circular path, there must be a net force acting on this satellite. And what should be the direction of this net force? it must be direct to the center of the circular path. So here we can see the center of its circular path is the center of Earth, and therefore on the satellites there should be a net force acting which should direct to the center of the Earth. Then only the satellites can continue to move in circular path. Therefore, the direction, net force, resultant force or net force direction must be in the arrow pointed towards the center, so that the correct answer is option D. Question 8. A tennis ball has a mass of 57 gram. A tennis player hits the tennis ball with a tennis racket. The tennis ball has a velocity of 25 meters per second when it hits the racket. The velocity of the tennis ball when it leaves the player's racket is 15 meters per second in the opposite direction from its approaching direction. The average force exerted by the tennis racket on the ball is 35 Newton. For how long is the tennis ball in contact with the tennis racket? So in this question we are provided with the mass of the ball, its initial velocity when or before it hits the racket, and the final velocity or the velocity of the ball after leaving from the racket, that is we can represent it with V, and the force exerted by the ball on the racket is also given. We need to calculate the time, how long the tennis ball in contact with the tennis racket. So in this question we have a tennis racket and a ball which is initially falling or hits the racket, and after it hits it's bounce back. So we have the initial speed of the ball before it hits the racket, which is 25 meters per second, and the final speed of the ball when it is leaves, that is 15 meters per second. So we can see its direction of the motion of the ball is in opposite direction. Before it hits it's moving towards right, after it hits it's moving towards left. So the value of velocity, if we are considering the right velocity is positive, the velocity of the ball when it is moving towards right we have to consider as negative. So the initial velocity of the ball will be negative 25 as it moving towards right, but the velocity of the ball when it is moving towards left after hitting the racket we can consider as positive 15. This is the important concept we should think while solving this question, and it's because the velocity is a vector quantity, so we have to consider its direction also. Now we can use the equation. Force is rate of change of momentum, where change in momentum is mass into change in velocity, that is final velocity minus initial velocity over time. So here we have to calculate time. So we can make time as the subject. Therefore we will get time is equal to mass times final velocity minus initial velocity over force. We have the values we can substitute. Mass of the ball is given, that is 57 gram. So 57 we need to convert gram into kilogram. So we should multiply with 10 to the power minus 3 times the final velocity is 15 minus the initial velocity is minus 25 over force is 35. So we will get 57 times 10 to the power minus 3 times 15 minus minus 25 is 40 over 35, and the final answer is 0.065 seconds. Therefore, the correct answer is option C. Question 9. This question is about 4 methods used to produce electrical energy. Which method has a correct description? Option A, method hydroelectric power station. And in hydroelectric power station, it is an energy source which is renewable, and that is correct. Yes, it's renewable and it's emit carbon dioxide. No, it does not emit carbon dioxide. So both these descriptions are correct about hydroelectric power station. So the option A is correct. Anyway, we can look at other options also. Option B says that a coal fired power station which is not renewable, or it's not renewable, that is correct, which emits carbon dioxide. We know that a coal fired power station emits carbon dioxide, but here in the option it says it's no. So this is wrong. Therefore, option B is not a correct answer. Option C says that a wind turbine, and it says this energy resource is renewable, but it says no, but it is a yes. It should be yes, because wind turbine is a renewable energy source. So this option is also wrong. Option D, a nuclear power station energy source is renewable. No, it is not. But here it's mentioned yes, so that's also why this option is also wrong. So the correct answer is option A. Question 10. A stone is released from rest from a high building on earth. Air resistance is negligible. What is its velocity when it has fallen 5 meters? So in this question, it's given that a stone, initially it is at rest. So its initial velocity is 0, which is falling, and after traveling 5 meter distance, we need to calculate what will be the new velocity of the stone, or the velocity of stone after falling 5 meter height. In this question, time is not given. Only we have initial velocity 0 and the total distance traveled. Distance traveled, we can represent that with letter S, which is 5 meter, and we need to calculate what is final velocity. When we observe the motion of this stone, we can understand the stone is moving in straight line, or it is a straight line motion. And second point, there is a uniform acceleration because there is no air resistance. So the only acceleration on this stone will be acceleration due to gravity, that is 10 meter per second square. So we can understand uniformly accelerated motion. The motions which satisfy these two conditions, that the object should be moving in a straight line and it should be uniformly accelerated, we can use 3 sets of equation. The equations are V, final velocity, is equal to initial velocity plus half acceleration times time square. U plus acceleration times time, V is equal to U plus AT. Second equation is V square, that is the square of final velocity, is equal to U square, that is the square of initial velocity plus 2 times acceleration times the distance traveled by the object, which is represented by S. And the final equation is S, that is the distance traveled by the object, is equal to initial velocity times time plus half times acceleration times square of the time. So these are 3 equations known as equations of motion, which we can use for the motions in straight line and uniformly accelerated. So we can use one of these equation here in this question in order to calculate the velocity, but we know that there is no time is not given, so we cannot use the equation V is equal to U plus AT, because there we need to know time. Likewise, the third equation also consists of time, that is S, distance, is equal to U times time. So the third equation also we can't use, because if we need to use first and third equation, we need to know the time, but we don't know the time. But we can use the second equation. The second equation is V square is equal to U square plus 2AS, where we have U and S values, so we can substitute before that. Here we have to calculate velocity V. So in this equation, we know that V square is equal to U value is 0. So we don't have to consider U part because it's 0. So we will get 2. Instead of AS, you can write GS, because here the acceleration on this stone is acceleration due to gravity because it is under free fall. So instead of using the acceleration letter A, we can use the acceleration g times x. In order to calculate velocity, we have to simply take v, not v square. So v will be square root of 2gs. Now we can substitute the values. Square root of 2 times g is acceleration due to gravity, which is constant, that is 10, times s is the distance travelled by the stone, which is given 5. Therefore, we will get 10. 10 meter per second is the velocity of the object or velocity of the stone under free fall when it travels 5 meter. Therefore, the correct answer is option B. Question number 11. The power input of an electric motor is 400 watt. The efficiency of the motor is 85%. How much power is wasted? So we need to calculate the wasted power. The input power is given. Efficiency is also given. So in order to calculate wasted power, we can use the equation of efficiency. So the equation of efficiency is equal to useful output power over total input power times 100. Now we can substitute the values given. Efficiency is given, that is 85, is equal to useful output power, which we don't know. So we can simply write useful output power over input power is given, that is 400 watt times 100. From this we can calculate what is the value of useful output power just by making the useful output power as a subject of the equation. So we will get useful output power is equal to, we have to take 400 and 100 to the other side of the equation. So we will get useful output power is equal to 85 times 400 over 100. And the answer is 340 watt. So now in this question we can see for an electric motor, the total input given into the electric motor was 400 watt. Out of that, only 300 watt consumed for a useful output. So the remaining will be wasted. So we can calculate the power wasted is the total input power minus useful power. That means we need to subtract the total input power and useful output power. So we will get what was the wasted power. So we have 400 is the total input power given to the motor. Out of this, only 340 watt is consumed for a useful work. So the remaining power will be wasted, and that is 60 watt. Therefore, the correct answer is option A. Question 12. A book has a mass 400 gram. The surface of the book in contact with the table has dimensions 0.10 meter and 0.20 meter. The gravitational field strength G is 10 Newton per kg. What is the pressure exerted on the table due to the book? In this question, we need to calculate pressure. So we can use the equation pressure is equal to force over area. Here the force is nothing but the weight of the book over area of the book which is in contact with the table. So weight is nothing but mass into gravitational field strength over area. We have the values we can substitute. Mass is 400 gram. So we need to convert gram into kilogram. So we have to multiply with 10 to the power minus 3. So this is the mass in standard unit. Kilogram times G is 10, which is already given, over area of cross section, that is the length and breadth, length times breadth. So that will be 0.10 times 0.20, and the answer is 200 Newton per meter square. The correct answer is option D. Question 13. A horizontal metal plate of area 0.50 meter square lies at the bottom of a lake at a depth of 40 meter. The density of the water is 100 kg per meter cube and the gravitational field strength G is 10 Newton per kg. What is the downward force acting on the plate due to the water? So in this question we have an horizontal plate with an area of cross section. The area of this plate is given, which is 0.50 meter square. That is the area. Now this plate lies at the bottom of a lake. So there is a lake. This plate lies at the bottom of the lake at a depth of 40 meter. So the depth or the height above this plate of the water level is given, that is 40 meter, and the density of the water is also given, that is 1000 kg per meter cube. We need to calculate what will be the force acting on this plate due to the water staying at the top of the plate. So here we can use the equation again. Pressure is equal to force over area. But in this question we need to calculate force. So we can make force as the subject. So we will get force is equal to pressure times area. Where what is the equation of pressure? Pressure in a fluid equation, pressure is equal to rho gh, density of that liquid times gravitational field strength times the height of the liquid. So we can use that equation here. Instead of pressure it is rho gh times area. Now we have the values, we can substitute. Density is given, that is 1000 times G is 10 times height is 40 times area of cross section is 0.50. Therefore the answer is 200 kilo Newton. Option C is the correct answer. Question 14. Which row describes the forces between the molecules and the motion of the molecules in a gas? When we look at the molecules arrangement in solid, liquid and gas, we can see in solids the molecules are close to each other. It is because there is a strong force of attraction, or the forces between the molecules are very strong. That's why they are staying close together. But when we look at the molecules of gas, we can see there is a big space between the molecules. From these we can understand the forces between the molecules are very weak. That's why they can separate each other and move freely. So when we look at the forces between the molecules in gas, it is weak. Therefore option A and B is wrong. Now we have to look at the motion of molecules. Again we can look at the molecules in gas. There we can see the molecules. Each molecules are separated and there is a big space between them. So they are free to move. They will move freely to any direction. Because molecules have a lot of space. So the vibrates only is wrong, but they can move freely. Therefore the forces between molecules is weak and they can move freely. Hence the correct answer is option C. Going to question 15. Very small pollen grains are suspended in water. A bright light shines from the outside. When looked at through a microscope, small specks of light are seen to be moving in random, jerky manner. What are the moving specks of light? This question is about Brownian motion. So in a container we have taken water and very small pollen grains are suspended in water. So you can see when we are looking through the microscope, we can see these pollen grains. Pollen grains we can see because their size is comparatively greater than the molecules of water. But molecules of water we cannot see even through the microscope because they are such a small particle. So now this container consists of two types of particle. One is molecules of water and the second one is pollen grains, where the size of the pollen grain comparing to the molecules of water are greater. So the pollen grains can be seen by microscope. Only we can see pollen grains. Molecules cannot seen by microscope as their sizes are very small. So this is the first thing we should know about Brownian motion. When we let the bright light to pass through this water, these lights will strike on these pollen grains. They have comparatively a bigger size, and when the light strikes, it will reflect so that we can see these pollen grains, and they will be moving in random direction like straight line but to any direction in a zigzag manner. So this is what we can see through the microscope. We can see the pollen grains, they are moving in random jerky manner. Now the question is why the pollen grains are moving. So when I am drawing the pollen grains here, suppose these are some pollen grains, and when we look at the water through a microscope, we can see these pollen grains are moving in random direction. But what is the reason behind it? What causes these pollen grains to move randomly? It is because of the water molecules, which we cannot see through a microscope, but water molecules are there. Even though their size is very small, millions of water molecules are present in this container, and these water molecules will be continuously moving in random direction. So if we can zoom it, we can see these water molecules also moving continuously with very high speed and in random direction. So these water molecules will hit these pollen grains continuously, which will cause the pollen grains to move in random direction. But we can see only pollen grains. We cannot see the water molecules are hitting the pollen grains, and because of that the pollen grains also moving in random direction. Now we can look at the options. What are the moving specks of light? That we already discussed. These are pollen grains. We cannot see water molecules because their size is comparatively very small. Option A says pollen grains being hit by other pollen grains. That is wrong. The pollen grains being hit, that is correct, but not by other pollen grains, but it is by water molecule. So the option A is wrong. Option B says pollen grains being hit by water molecule. That is correct. Let's check other options. Option C says water molecules being hit by other water molecules. No, we cannot see water molecules. Option D is also saying we can see water molecules, which is being hit by pollen grains. Just opposite thing is happening. So the correct answer is option B. So this point is very important. Pollen grains being hit by water molecules. It can be pollen grains or smoke particles or dust particles, which will be being hit by the water molecules or gas molecule where it is suspended. Question 16. A hole is drilled in a metal plate. What happens to the length of the plate and the diameter of the hole when the plate is cooled? So here we can see when the plate is cooled, what happens to its energy? Energy of the molecules or atoms in the plate will reduce because temperature is proportional to energy. The more temperature the molecules will have, the more energy the molecules will have. So when we are cooling something down, its temperature reducing so that the energy will be less. When the energy reduces, the molecules won't be vibrating faster, So there won't be not much space in between these molecules. So we can say they come closer. The molecules will come closer. So which will cause that metal plate to shrink. So when a metal plate shrinks, what happens? Its length will decrease and even the diameter of the hole also will decrease because it totally shrinks. Therefore, the correct answer is option A. Question 17. Which statement describes a sensitive liquid in glass thermometer? So we need to know how we can describe a liquid in glass thermometer which should be a sensitive liquid in glass thermometer. Here initially we can look at the word sensitive. What is the meaning of a sensitive liquid in glass thermometer? High sensitive liquid in glass thermometer will give large increase in the length of liquid column for each degree of temperature rise. That means even though there is 1 degree temperature has increased, it will be easily visible from the thermometer because the liquid will expand large enough which will be noticeable. So this is the definition of the sensitivity of a liquid in glass thermometer. And you need to know how can we increase the sensitivity of a thermometer. The narrower the tube, the more the liquid inside moves, making the thermometer more sensitive. But anyway, you don't need that two ways how to increase the sensitivity in this particular question. Here you just need to know what is meant by sensitivity. So option D is correct. Question 18. A block of aluminium of mass 2 kg has an initial temperature 20 degrees Celsius. It absorbs 7,300 joules of thermal energy. The specific heat capacity of aluminium is also given. What is the final temperature of the aluminium block? So here we can use the equation of specific heat capacity. That is the thermal energy required is equal to mass times specific heat capacity times change in temperature. Here we have the energy absorbed and mass is also given and the specific heat capacity is also given. So we can calculate the change in temperature. So we can make change in temperature as a subject. So we will get energy over MC where energy is 7,300 over mass is 2 times specific heat capacity is 913. And we will get change in temperature is 4 degrees Celsius. So now we have change in temperature, that is nothing but the final temperature of the aluminium blocks minus the initial temperature of the aluminium block. Now we have calculated the change in temperature and initial temperature of the aluminium block is already given in the question. Therefore, we can calculate the final temperature. For that, we need to make final temperature as a subject. So, we will get final temperature is equal to change in temperature plus initial temperature. This initial temperature will go to the other side of the equation. So, it will become plus. Now, the change in temperature we have calculated 4 degrees Celsius plus initial temperature is given 20 degrees Celsius. So the final temperature is 24 degrees Celsius. Correct answer is option C. Question number 19. A student sets up 4 cans. Each can contains the same mass of water at 90 degrees Celsius. The cans are identical except for the outside surface. Which can will cool down the fastest? So we have a can, 4 cans which consist of all the 4 cans consist of water with 90 degrees Celsius. And we need to check which can will cool down the fastest. So how can this can will cool down fastest? The temperature inside the water should be able to absorb by the can easily and it should let the heat waves to go out of the can easily, quickly. then only the can will cool down shortly. In order to cool down fastest, we should choose the surfaces which should be absorb the heat faster, and the absorption is more for the materials or the surfaces which are in dull black color. So absorption of heat will be more for the colors or the surfaces with the colors dull and black surface. So here the can with the dull and black surface will absorb the heat from the water and let it to pass through this material, and it will let it to go out easily. Therefore option A, dull black surface, is the correct answer. Question 20. Thermal energy is transferred by conduction in a metal bar. Which statement is not correct? In metal bars, thermal energy is transferred basically by two ways. The first one is ions or lattice of ions vibrate and strikes neighboring ions, and these ions will be staying in the same place. That is also important point. These vibrating ions will be staying in the same place only. They cannot move, but they vibrate and strike neighboring ions. So the neighboring ions will also starts to vibrate. So this vibration will continue. This is how the thermal energy is transferring in metal. And one more way the thermal energy will be transferring in metal, that is the free electrons. They will carry this thermal energy and they move through the bar. That is also important point. These free electrons can move freely through the bar from one side to the other side or metal rod. Therefore, these are the two important ways in which the thermal energy transfer in metals. Through ions, the vibration of ions, but the ions will stay in the same place, but the vibration will carry to the other ions. But for free electrons, they can carry this heat energy and they can freely move itself to one part to another part. Let's look at the options. Option A says fast vibrating ions leave the surface. This is wrong. The ions cannot leave or move from one place to another place. They are at a fixed place. So the option A is a wrong statement. Therefore, the correct answer is option A. Question 21. A water wave passes into a region where the wave travels more slowly. As it passes into slow region, what happens to the frequency and what happens to the wavelength of the wave? So in this question, a water wave which started to move more slowly, that means its speed has reduced, velocity reduced. In this case, what will happen to its frequency and wavelength? So here let's see what is frequency. So frequency of a water wave is the number of water waves produced in a second, which is completely depending on the source which produces these water waves. So that the frequency is not going to change when the speed of the wave or speed of the water wave reduced, because the number of waves produced in 1 second will be still same. So from this we can understand frequency will remain same. So this is a very important point we should understand, that when the speed of a water wave increased or decreased, the frequency of a water wave is not going to change, as it only depending on the source which produces the wave. Now we can see what will happen to wavelength. For that we can look at the equation, wave equation, that is speed of a wave is the product of frequency and wavelength. This is very important wave equation. Now by looking at this equation, we can check about the wavelength. What will happen to the wavelength when the speed reduced? So here the velocity has reduced and we know that the frequency will remain same. Therefore, the wavelength will definitely reduce, which we can understand from the equation. Because the LHS of a equation has reduced means the RHS of the equation also should reduce. Where frequency cannot reduce, it will remain always same. So definitely the wavelength must have to be reduced. So we can understand wavelength decreases but frequency remains same. Therefore the correct answer is option C. Question 22. Light travelling at a speed of 3 into 10 to the power 8 meter per second strikes the surface of a glass block and undergoes refraction as it enters the block. The diagram shows a ray of this light before and after entering the block. What is the speed of light in the glass? In order to calculate the speed of light in the glass, here we have to use two equations. The first one, refractive index, is equal to sine of the angle of incidence over sine of angle of refraction. Using this equation, we can calculate refractive index. After calculating the value of refractive index, we can use the second equation, that is refractive index is equal to speed of light in vacuum over speed of light in the glass. In the question, angle of incidence and angle of refraction are given, so we can substitute. Then we will get refractive index, that is sine 55 degree over sine 33 degree. Sine 55 over sine 33 degree is 1.5. Now we have refractive index. After getting this value, we can use the second equation, that is refractive index is the speed of light in vacuum over speed of light in the glass. In this question, we need to calculate the speed of light in the glass. Therefore, we can make the speed of light V as the subject. We will get V is equal to C over refractive index. C is the speed of light, that is 3 times 10 to the power 8, which is given. Over refractive index we have calculated, that is 1.5, and the answer is 2 times 10 to the power 8 meter per second. Correct answer is option B. Question 23. Which statement about the image of an object formed in a plane mirror is correct? So the statement about the image formed in a plane mirror. Let's look at the properties of the image formed in plane mirror. That images will be virtual, that is the first property. Then it will be erect. And the third property is same size as that of the object. Now we can look at each options. Option A says it is smaller than the object. But we have seen about the size, it will have the same size that of the object. Therefore, option A is wrong. Option B says it is the same size as the object. And yes, that we have already seen. Let's check other options too. Option C says the image is larger than the object. That is wrong because it will have the same size and it is inverted. No, the object will be erect, not upside down. Correct answer is option B. Question 24. An object is placed in front of a thin converging lens. The diagram shows the paths of two rays from the top of the object. So we can see a converging lens and an object has kept to the left side of the lens, and the path of two rays from the top of the object is shown. One ray is moving parallel to the principal axis and it will be passing through the principal focus, and another one is passing through the center of the lens. Let's continue reading the question. An image of the object is formed on the screen to the right of the lens. So an image has formed. How does this image compare with the object? So we need to compare the image and the object properties. So let's draw the image. For that we have to complete the diagram. First we can concentrate at the first ray, which is actually emerging from the object and moving parallel to the principal axis. When it crosses the converging lens, what will happen to this ray? As it is a ray which is moving parallel to the principal axis, once it is converging from the lens, it will always pass through the principal focus and it will move straight. It will continue to move in the principal focus. Therefore, this will be the path of the first ray. We can put the arrow to indicate the direction. Now we can look at the second ray. The second ray is passing through the center of the converging lens. So the rays passing through the center of the lens, it will not deviate but it will continue to move straight. So we can complete the second ray also. As we discussed, without any converging or without any deviation, this ray will move to continue in straight line. Now we can see these two lines or these two rays are intersecting at a point. So the image will be formed at this point. So we can draw a line to connect from the principal axis to this intersecting point. So this will be the image formed. Now we can compare the size of the object and the image, and it's clear that the image formed is larger comparing to the size of the object. And one more thing, the image is inverted. You can see the object pointing upwards whereas the image is pointing downwards. So the image is inverted comparing to the object. So that is the second point we can conclude from the figure. Let's look at the options. Option A says it is larger and inverted. That is correct answer, which we have already discussed. Option B, it is larger and the same way up, but it is inverted, not the same way up. Option C, it is smaller and inverted. It's not smaller, it is inverted, but it is not smaller. Option D says it is smaller, it is same way up. Both the statements are wrong. Therefore, the correct answer is option A. Question 25. Here are three statements about the speed of electromagnetic waves. 1. The speed of electromagnetic wave is in a vacuum is 340 meter per second. 2. The speed of an electromagnetic wave in a vacuum is 3 times 10 to the power 8 meter per second. 3. The speed of an electromagnetic wave in a vacuum is approximately the same as in the air. Which statement are correct? Statement 1 is wrong because we know that the speed of an electromagnetic wave, for example a light wave, is very high and its value is 3 times 10 to the power 8 meter per second. It's a constant value. So a value like 340 is too small. Therefore, first statement is wrong. Statement 2 is correct. The speed of an electromagnetic wave is 3 times 10 to the power 8. So the second statement is correct. Third statement says the speed of electromagnetic wave in vacuum is approximately the same as in air, and that is also correct. When we do the questions calculations for an electromagnetic wave, whether it is a light or radio waves or any type of electromagnetic waves, we will consider the speed of that wave is 3 into 10 to the power 8 meter per second. Whether it is in vacuum or in air, we have to consider as the same value. The reason is both the speed approximately the same. So the statement 3 is also correct. For question number 25, the correct answer is option C. It only says the statements 2 and 3 are correct. Question 26. The sound from a loudspeaker must pass through two materials to reach a microphone. Which combination of the materials give the shortest time for the sound to reach the microphone? The shortest time for the sound to reach the microphone. So the shortest time means highest speed. When speed is more, the wave will take shorter time to reach to the microphone. So there is a loudspeaker, it will produce the sound waves, and the sound wave has to travel through two materials, and we have to check what should be these two materials from this given option in order to reach the sound wave with maximum speed. Here we should know very important point that the sound wave travels faster and more effectively in liquid than in air, and travel even more effectively and faster in solids. So when you compare the speed of sound in different matters, we can understand speed of sound in solid is greater than the speed of sound in liquid, and speed of sound in liquid is greater than the speed of sound in air. From this we can understand the sounds travel faster in solids. So if the material 1 and material 2 both are solids, then the sound will take the shortest time to reach to the microphone. So we can look at the options. In option A, it's material 1 is air, then material 2 is hydrogen. So we have already seen speed is very less in air, so this won't be possible answer. Option B is also contains air. So in air speed is less, or the sound wave travel slower. Option C says copper and aluminium, and that is possible because both are liquid. So correct answer is, both are solids, so that the correct answer is option C, because in solids the sound travels faster. Option D consists of two liquids, but in solids the speed is more greater. Correct answer is option C. Question 27. Which method does not demagnetize a bar magnet? So before going to the options, let's check what are the methods to demagnetize a magnet. So to demagnetize, the first method is hit the magnet with a hammer. Magnet plays in east-west direction. So when we are hitting the magnet, we have to make sure the magnet has kept in a east-west direction. This is one way to demagnetize a magnet. And the second method, heat the magnet to a high temperature and place the magnet in east-west direction. The third method is place magnet within a solenoid and pass an alternating current through it. So these are the methods to demagnetize a magnet. Now we can look at the options. Option A, heat the bar magnet and place it in the east-west direction to cool. That is a correct way to demagnetize. Option B, place the bar magnet in the east-west direction and hammer it. That is also a correct way to demagnetize a magnet. Option C, place the bar magnet in a coil, connect to an AC supply and slowly withdraw it. This option is also correct. Option D, place the bar magnet in a coil connected to DC supply and slowly withdraw it. This is wrong. It should be AC. Therefore, using the method mentioned in option D, we cannot demagnetize a bar magnet. Correct answer is option D. Here to demagnetize, you can add one more point in the third way of demagnetizing the magnet, that place bar magnet within a solenoid and pass an alternating current pass through it, and we need to withdraw it slowly. So that is one additional point we can write, slowly withdraw it. So these are the three methods. Question 28. Three pails of small nails P, Q and R are placed on a bench below three electromagnets. One set of nails is made of copper, one of soft iron and one of steel. Diagram 1 shows the situation when the electromagnets are switched on. Diagram 2 shows the situation when the electromagnets are then switched off. So three pails of small nails are available, P, Q and R. Initially, all of them were on the bench. But in diagram 2, we can see what happens to these nails P, Q and R, which were staying at the bench once the electromagnets are switched on. So the electromagnets are switched on means there should be a connection. This switches should be on or closed. In this case, there will be a current flowing through the coil and which will cause these coils to behave same as a bar magnets. So once the switches are on, there will be electricity. Because of that, these coils will behave as a permanent bar magnet. So the coils will have magnetic field around it. So now in diagram 2, these coils are actually bar magnets or magnetic properties they have. So they are electromagnets. And because of this magnetic property, you can see the nails Q is attracted and nails R is also attracted to the coils. From this we can understand that these nails Q and R must made with a magnetic material. Then only these materials or these nails will get attracted. Whereas when you observe nails P, we can see even though the switch is on, it is behaving as a magnet. Still the nails P is not attracting to the magnet. That means the nail P is made with some materials which are not magnetic or not with a magnetic material. That's why they are not getting attracted. Now we can go back to diagram 2. In this diagram it is mentioned that the switches are open. So these electromagnetics, once the switch is on in diagram 1, they were behaving as magnets, but once the switch is open, they will lose its magnetic property. Then they won't act as magnets anymore. But still we can see the nails is still attached to these electromagnets. So this nail must be made up of a material which should be steel, because steel is slow to be magnetized but it can retain the acquired magnetism for a long time. So the steel will behave as a magnet for a long time even though there is no current in electromagnet. But for nail Q, what happened? The moment the switch is open, the nail Q fall down. The reason is the nail Q with a material which is a magnetic material. That's why they get attracted. But this material cannot retain its magnetic property for long. Once the switch is open, it lost its magnetic property completely. So this material should be soft iron. Therefore, we can conclude Q is soft iron. And we have already seen in diagram 1 itself, P is not at all a magnetic material, or we cannot recognize much because it's not getting attracted. So, P must be copper. Therefore, the correct answer is option A. Question 29. A magnet is suspended by a cotton thread. The magnet is displaced, then allowed to swing freely until it comes to rest. Why does the magnet always come to rest pointing in the same direction? When a magnet is suspended by a cotton thread freely, we can always see the magnet come to rest pointing in the same direction. Always this north pole of the magnet will come to this side and south pole of the magnet will come to the other side. The reason for it is our planet Earth has two magnetic poles, the north magnetic pole and the south magnetic poles, just like a bar magnet. So we can consider our Earth itself as a magnet with a north magnetic pole and a south magnetic pole. Or we can consider as a magnetic bar, a huge magnetic bar with the poles as shown. So now we have a secondary magnetic bar, and we have already learned always opposite poles attract. So automatically the north pole of the magnet which we have suspended will get attracted or will point to the south pole of the earth magnet, and that part of the earth magnetic field is called north magnetic pole. So it is because of the interaction between the magnetic field of the bar magnet and the magnetic field of the earth. So the correct answer is option D, which says it is because of the interaction between the magnetic field of the magnet and the magnetic field of the earth. So when both the magnetic fields come together, either one side will repel and the other side will attract. Question 30. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What happens to the rod? So there we have a plastic rod and a piece of a cloth. When the student rubs the plastic rod with the cloth, the rod becomes positively charged. That means the rod's charge is positive. So we can think how the rod will become a positively charged object. It's only possible when the electrons loses from the object or from the rod. Negatively charged electron must have moved to the cloth. So what will happen? The number of electrons in the cloth will increase, will be greater than the number of electrons in rod, and the rod is actually initially the number of positive charges and number of negative charges were equal, so that it was a neutral object or there was no charge, but once it loses electrons it will become positively charged object. So this is what happens. The rod is actually losing some of the electrons to the cloth. So here the rod has lost electrons. Correct answer is option C. Here first important point you need to know that losing electrons will make an object to be positive charge, and only electrons can move. Negatively charged electrons can move, not the protons, as protons are staying inside the nucleus. Positively charged protons cannot move from one object to another object, but the negatively charged electrons will be moving. It will be losing from one object or gaining to the other object. So that is most important point. Electrons are the only particles which can move from one object to another object, and losing electrons will cause that object to become positive charge, and gaining electrons will make that object to become negative charge. Therefore, if you know this concept, you can easily answer this question. Here the rod has become positively charged, that means it must have lost some electrons. Question 31. An isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. What happens to the charges on the neutral sphere as the positively charged sphere is brought close to it? So here we can see we have two spheres. The first one is filled with positive charges, but the second one is neutral. Neutral means number of negative charges and positive charges will be same. That means, for example, if there are 5 negatively charged particles, there will be 5 number of positively charged particles present. So the total number of positive charge is 5, total number of negative charge is also 5. So the total charge will be 0. That's why we can call it as a neutral sphere, or there is no charge in the second sphere. Now when we bring these spheres together, what will happen? or when you bring one sphere close to the other one, what will happen to the charges in the second sphere? Here, the negative charges in this sphere will move to the positively charged sphere, because we know that the opposite electrical charges attracts. So the negative charges will get attracted to the positive side. So here the important point is only negatively charged particles will move. They can only move. The positively charged particle, that is proton, which cannot move, they can only stay inside the nucleus. So we can check what happens to the charges on the neutral sphere. Option A says some positive charges moves to the left. That is wrong. Positive charges cannot move. Option B says some positive charges moves to the right. That is also wrong, because positive charges cannot move. We have already discussed that. Option C says some positive charges moves to the right. Again it says like that, so it's not correct. Option D, the positive charges do not move. That is correct. But some negative charges moves to the left. Yes, we have seen. The negatively charged particles will move to the left side, so that they are very close to the positive charged sphere. So it's because of the opposite charges attracts. Therefore, the correct answer for this question is option D. Question 32. Which circuit has a 0 reading on the ammeter? So 0 reading on the ammeter means the current in that circuit should be 0, or there won't be any current flowing through that circuit. So we have to identify out of these 4 circuits, in which circuit there should not be any current flowing. Then only we will get a 0 reading on the ammeter. So we can look at option A. We have a cell which is connected in series with an ammeter. So the ammeter will read the current passing through this, and that current will be flowing through a resistor and through a diode. And you can see diode, the positive side of the cell is connected to the positive side of the diode. So the other side is negative, so the current will pass through this diode. So you should know the property of a diode. Diode has 2 sides. This side is known as positive and the other side is known as negative. And diode act as one-way switch for current. So that is the property of a diode. It acts as a one-way switch for the current. That means if you have a cell, and you know the cell or a battery, it will have a positive and negative side. So this is positive and this is negative, and if you are connecting a diode to it, you can connect in 2 ways. Either this way, where positive of the diode is connecting to the positive of the cell, or you can connect the diode in opposite way, where the negative of the diode should connect to the positive of the cell. So these are the 2 different possible connections with the diode. So in first one you can see the positive side of the cell connected to the positive side of a diode. So when you connect the diode in this way, it is known as the diode is forward biased. In this case only the diode will let the current to flow. That means there will be a flow of current from positive terminal of the battery, and it will pass through the diode and it will reach to the other side of the battery. But if you look at the second figure, as the positive side of the battery is connected to the negative side of the diode will block the current. Therefore, no current will be flowing through this circuit. This is called the diode is connected reverse bias. So we have to make sure, in order to let the current to flow, we should always connect the diode as seen in the first diagram. So in option A, the positive side of the cell is connected to the positive side of the diode so that there will be a current flow. If there is a current flow, there will be a reading on the ammeter. But here we should choose a diagram or circuit where ammeter reading should be 0. So for option A, the ammeter reading won't be 0. So this is not a correct answer. When we look at option B, we can check whether the diode is connected forward or reverse. So the cell positive side is connected to the positive side of the diode. So there will be also a current. So there will be a reading on the ammeter. Therefore, option B is also wrong. We can look at option C. The positive side of the cell is connected to the positive side of the diode. Then again, the other diode is also connected in the same way, positive to negative. So there will be a current flow in option C also. Option D, the positive side of the cell is connected to the positive side of the diode, so that the first diode is forward biased. So there will be a current. But when you look at the second diode, you can see the positive side of the cell is connected to the negative side of the diode, or negative side of the cell is connected to the positive side of the diode. So this diode is reverse biased, and we have already seen in this case the diode will not let the electricity to flow, but it will block the current so that there is no current in this circuit. Hence the ammeter read will be 0 ampere. Therefore the correct answer is option D. Question 33. Two 10 ohm resistors are connected in series and then in parallel. What is the combined resistance in each case? So we can take the first case where two 10 ohm resistors connected in series. So when you connect two 10 ohm resistors in series, the R total, we can use the equation, combined equation, or the equation for combined resistor for series circuit will be, series connection will be R1 plus R2. We need to simply add, and it will be 10 plus 10. So we will get 20. That is the R total when the resistors connected in series. Now we can see what will happen when we connect these resistors in parallel. In this case, we will combine or connect these two 10 ohm resistors in parallel. So here we have to use the equation 1 over R1, or R total is equal to 1 over R1 plus 1 over R2. That is 1 over R total is equal to 1 over 10 plus 1 over 10. We will get 0.2, that is 1 over RT. In order to calculate RT, we have to take the reciprocal, that is 1 over 0.2. And the answer is 5 ohm. So the combined resistor for the series connection it is 20 ohm, and for parallel connection it is 5 ohm. Therefore the correct answer is option C. Question 34. The diagram shows a combination of 4 logic gates that produce an output signal at R that depends on the state of the inputs P and Q. Which single logic gate produces the same effect as the combination? So initially we can check the truth table of the given combination. Here we have two inputs P and Q and one output R. So P and Q are the inputs and R is the output. We can check different input combinations starting with 0, 0, 0, 1, 1, 0 and 1, 1. For these input values, what will be the value at output for this combination? We can check that. So first, for the first input combination, that is 0, 0. When the inputs are 0, 0, what will be the output? For that, first we can check the output at each NOT gate. When we connect 0, 0, it will be the NOT, that is just the opposite sign. So we will get 1, 1. Now these inputs 1, 1 are going to a AND gate. So we can see what is the truth table of an AND gate. So for AND gate, the truth table is when the inputs are 0, 0, the output will be 0. When the input is 0, 1, the output will be 0. When the inputs are 1, 0, again the output will be 0. And when the inputs are 1, 1, the output will be 1. This is the truth table of AND. With this help of this truth table, we can find out what will be the output at the AND gate. When the input at the AND gates are 1, 1. When the input at the AND gates are 1, 1, the output will also be 1. So for this, output will be 1. And when we connect this 1 to a NOT gate, we will get output as 0. So here at R, we will get a value of 0. Now we can check the output at R for the second input combination, where one input should be 0 and the other input should be 1. So when 0 connected to the NOT, we will get 1. When 1 connected to the NOT, we will get 0. So for an AND gate, when the inputs are 1 and 0, we can see when the inputs are 1 and 0, the output will be 0. So the output of the AND gate for 1 and 0 will be 0. So the output of NOT for an input 0 will be 1. So for the second input combination, we will get an output as 1. Now we can check the third input combination, that is 1, 0. So the inputs at P should be 1 and at Q should be 0. For this, we can check when the input is 1, 0. The output at the NOT gate will be 0, 1, just opposite. Now for the AND gate, when the inputs are 0, 1, we can see the output is 0 again. So we will get a 0 output and the NOT of this will be 1. Therefore, for the third combination inputs, the output will again 1. Now we can look at the last combination, that is when the inputs are 1, 1. So when the inputs are 1, 1, at the NOT gates, the output will be 0, 0. So for AND gate, when the inputs are 0, 0, the output also will be 0. So here we will get an output of 0. Not this 0, we will get 1. Therefore, the output at R will be 1. Now this is the truth table of the given diagram. Now we need to check which single logic gate produces the same effect of the combination, or we need to identify which logic gate has the same truth table as the truth table of this given combination. And by looking at the truth table, we can understand this is the truth table of a OR gate. Therefore, the correct answer is option D. Question 35. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. The ammeter shows that there is a small electric current in the solenoid while the rod is moving. Which rod is being inserted? So here we can see when this rod is inserted in the coil and when it is moving, there is an electricity or an induced EMF is produced, and it is because of the electromagnetic induction. So for the electromagnetic induction, there should be a change in number of magnetic field lines linked with the coil should keep change. That's why when the rod is moving, the number of magnetic field line linked with the coil is changing and a current is generating. In order to have a change in the electromagnetic field lines that is linked with the coil, this rod should be a magnet. Then only it will have magnetic field line around each. So when this coil or when the rod is inserted in the coil, these field lines will cut by the coil, which will produce a electricity. So the rod must be a magnetized steel rod. Correct answer is option B. Question 36. The diagram shows a transformer. What is the output voltage? We have provided here number of turns in the primary coil, voltage at the primary coil, and the number of turns in the secondary coil is also given. We need to calculate the voltage at the secondary coil. Here we can use the equation, transformer equation, that is Vp over Vs is equal to Np over Ns. Here we need to calculate Vs. So we can make Vs as a subject. Then we will get Vs is equal to Vp times Ns over Np. We can substitute the values where Vp is 22,000 times Ns is 115 over Np, that is the number of turns in primary coil, is 550, and the answer is 4600 volt. Correct answer is option C. Question 37. Which row correctly states how nuclei behave during nuclear fission and during nuclear fusion? In order to answer this question, we just need to know what is fission and fusion. So fission is a process in which nuclei splits apart, and fusion is a process in which nuclei join together. The correct answer is option C. Question 38. The charge on a proton is E. What is the charge on an electron and what is the charge on a neutron? So electron is a negatively charged particle and it has the same charge of a proton but opposite sign. So it must be minus E. Whereas neutron is a particle with no charge. So its charge is 0. The correct answer is option D. Question 39. Some radioactive nuclei decay to give new nuclei which are also radioactive. Part of a series of decays is shown. How many decays involves the emission of beta particle? So here we can see one nuclei decays and producing a new product, and this new nuclei again decay because that is also a radioactive, so that it become a new product or new radioactive element, and it's keep continuing. And we have given a part of a series of decays, and by looking at this series of decays we have to count how many decays involves the emission of beta particle. In order to answer this question, we can check what is a beta decay. Suppose we have a parent nuclei, let it be X, with atomic and mass numbers or number of protons is C and number of protons and neutrons, or the total number of nuclei is A. When it decays one beta, so it will produce a beta. So what will happen to the product? So a beta is always represented with -1 and 0. Here when the parent nuclei X decays a beta which is -1, 0, what will be the product? We will get a new nuclei Y, and we can check what will be the proton number and nucleon number of this product. In order to check that, we can use the concept that the proton number before and after decay should be same, the total number of protons. So initially if it is C, after the decay also it must be total number of protons should be C. So the proton number of Y should be C plus 1. Then we add the total sum of protons. At the RHS we will get C plus 1 minus 1 C. So the proton number is balanced at the both sides. Likewise, nuclei number for this Y product will be A, because for beta it is 0. So the total is supposed to be A in order to balance the nuclei number. Therefore we can see that the nuclei number is A at the both sides. This is a beta decay, or this equation shows how the element will change after a beta emission. Now we can understand, whenever there is a beta emission, the daughter element will have a proton number which will be 1 greater than the parent element. So here we can see in the given set of decays in which all parent elements and its product, there is proton number has increased by 1. So by comparing the values we can understand, here the proton number has increased by 2. So that is not correct. Here the proton number should only increased by 1. So in the first decay it is not emitting beta, but in the second one we can see the proton number has increased by 1. That means definitely it is a beta emission. Likewise, from PA to U also we can see the proton number has increased from 91 to 92, that is again plus 1. So one more beta decay. So here it has undergone a beta decay, and here also it has undergone a beta decay. But for the fourth decay it is plus 2. So that is not a beta decay. Likewise, the final decay also we can understand it's from 90 to 88. So it's minus 2. Again it is not, or it has not undergone a beta decay. So beta decay has occurred during these two decays. So the total number of beta particle decays are 2. Question 40. The graph shows the activity of a radioactive source over a period. The activity count is and the time is also given. What is the half-life of the source? So half-life is nothing but the time taken to become its activity or counts to the half of its initial value. So initially it was 120. Now the half of 120 is 60. So we should check when the activity is 60 or half of its initial value 120. What is the time? So we can see 2 minutes. That means the half-life of this given sample is 2 minutes. Or we can understand this sample will take 2 minutes to reduce its whole mass into half. Therefore, the correct answer is option B. Thanks for watching this video. If you find this video useful, please like this video and subscribe my channel. Thank you.